Mercury's special because it's the only metallic element that's a liquid at standard temperature and pressure. Its elemental symbol is Hg because it's based on its older and much harder to pronounce name. It used to be called hydrargyrum, which is the combination of the two Greek words hydror and argyros, which mean water and silver. The density of mercury is really high, so the small amount that I have here weighs a surprising 2.5 pounds. It's significantly denser than most other metals, so if we add something like a coin, it should float on top. Its melting/freezing point is around -39 degrees Celsius, so if we go below this, it's going to freeze solid. As it warms back to room temperature, it'll start melting, which I think looks pretty cool. It has a relatively low boiling point for a metal at only around 360 degrees Celsius. This makes it somewhat easy to purify by distillation, but I really don't recommend doing that, especially at home like I did, because it can be pretty dangerous. If something went wrong and boiling mercury spilled everywhere, it would be a disaster to say the least. Because of strong metallic bonding forces between mercury atoms, it has a really high surface tension. I don't want to go into much detail, but this causes the surface of the mercury to be drawn into itself in a way to minimize its surface area, ideally forming a sphere. In larger amounts, this isn't as noticeable because the effect of gravity is much greater than the surface tension, which causes the mercury to flatten out. However, as the volume decreases, the force of gravity gets less and less, and eventually the effect of surface tension can take over. When it does, it forces the mercury into a nearly spherical shape. Because it's a metal, it also conducts electricity, and this is taken advantage of to make various mercury-based electrical switches. There are many different designs, but the most common one is probably the tilt switch. If it's tilted in the right direction, the mercury will complete the circuit, turning on a light bulb or whatever the system is set up for. Mercury doesn't normally exist as a metal in nature, and it's usually found in the form of mercury sulfide, which is commonly known as cinnabar. Mercury sulfide exists in two forms, where one is red and the other is black. The red one is the most common, and because of its strong color, it was historically used as a pigment known as vermilion. Both of the forms can be converted to mercury metal, which is usually done by roasting it. With the strong heating, the mercury sulfide breaks down into elemental mercury, which is distilled off and collected. Although roasting it is the most common method, it can also be done chemically. Mercury sulfide is completely insoluble in pure water, but it can be dissolved in strongly basic solutions of sodium sulfide. Then, elemental mercury can be leached out of the solution by adding aluminum foil. The mercury that forms sinks to the bottom, which can be collected and cleaned up. An interesting property of mercury is amalgamation, where it forms alloys with other metals. Probably the most common example of this is the amalgamation of aluminum. Aluminum is normally surrounded by a protective oxide layer, but the mercury disrupts this and exposes fresh aluminum to the air. The aluminum quickly reacts and forms aluminum oxide, which grows as these white fibers. This releases the mercury from the amalgam, which can then go on to combine with more aluminum and continue the cycle. Even if all the visible mercury is cleaned up, some of it has seeped into the aluminum and it can continue to destroy it. This is the reason why you're completely banned from taking any amount of mercury onto an airplane. I posted a video last week that covers this process in more detail, and if you're interested in checking it out, there's a link in the description. In chemistry, this amalgamation cycle is commonly used for reductions. A small amount of mercury can continually expose fresh aluminum, which really likes to donate electrons. Metallic mercury isn't actually the best for this type of reaction though, and usually a more soluble mercury salt is used instead. Personally, I did this before in my process to make 1-octen-3-ol, which is a chemical attractant for biting insects. It's also used for a lot of other reactions, including some illegal ones, like the production of MDMA. Besides aluminum, though, mercury amalgamation is generally quite useful, and it's commonly used to do things like extract gold from gold ore, or to make dental fillings. In the future, I'm going to make a video, or maybe a series of videos, that's specifically dedicated to mercury amalgams. Anyway, in terms of toxicity, mercury metal isn't that dangerous. This is mostly because it doesn't absorb through our skin very well, and it also isn't super reactive. To really demonstrate this, Cody over at Cody's lab put his entire hand into mercury. Unfortunately though, I don't have nearly as much as he does, so I can only submerge a couple fingers. Although it isn't too toxic, it is important to thoroughly wash my hands afterwards, just to make sure there's no mercury left behind. It might be surprising, but the most dangerous thing about mercury metal is actually the vapor. The vapors are normally invisible, but we can see them if we blast them with some UV light. The mercury vapors absorb the UV, and they cast a shadow onto the paper. If the vapor is breathed in, it can be absorbed through the lungs, which is obviously not a good thing. However, small amounts are still not that bad unless you're regularly exposed to it. Mercury can form organic and inorganic compounds, and this is where the real danger comes from. The organic ones are the form that most people are exposed to because they're found in a lot of seafood. They tend to be highly fat soluble, which means they're easily absorbed through the skin as well as the digestive tract. There's a whole bunch of organic mercury compounds that exist, but the most infamous one is probably dimethylmercury. In 1997, it killed an organic chemist named Karen Wetterhahn after only a few drops fell onto her glove. It only took seconds for a fatal amount to quickly pass through both her glove and her skin. Generally less scary, but still dangerous, are the inorganic mercury compounds. In contrast to the organic ones, though, these tend to be more soluble in water. Their toxicity depends primarily on just how soluble they are, but it can be quite variable. Some of them, like mercury sulfide, are practically insoluble, so they're relatively safe to handle and touch. However, if for some reason you decide to swallow it, your stomach acid can react with it and make something more dangerous. On the other hand, here's some mercuric chloride that I made, which is highly soluble and quite toxic. I'm very careful when I use it, and I only work with it if I absolutely need to. An added danger to the acute toxicity of mercury is that it also tends to bioaccumulate. The organic mercury compounds tend to be much worse than the inorganic ones, but in general, mercury likes to stick around in your body and not be excreted. This means that small doses over a long period of time could eventually build to a toxic level. Another major consequence of this is a process known as biomagnification, where the level of mercury increases as we move up the food chain. When we get to the point of dolphins and sharks, the level can be so high that it's actually dangerous to eat on a regular basis. What I think is kind of funny is that nowadays we're so cautious with mercury compounds, but there was a time when they were purposely ingested as medicine. Mercurous chloride, or calomel, is probably the most famous example. It was used as a laxative or to treat syphilis, yellow fever, and various other diseases. Over the years, mercury-based pharmaceuticals have been more or less phased out and replaced with much safer alternatives. However, there are still some that are used. One of the most controversial ones is thimerosal, which is used in many vaccines as an antifungal and antiseptic agent. A lot of people claim that it causes autism in children, but there's never been any real proof of that. Industrially, mercury was used for a long time to make things like thermometers, batteries, and fluorescent lights, or to chemically produce sodium hydroxide and chlorine gas. However, just like with medicine, all of these uses have either been phased out already or will be phased out in the future. Anyway, in terms of reactions involving mercury, I've carried out quite a few on my channel. Mercury metal is relatively resistant to most acids, but it quickly reacts with nitric acid to form mercury nitrate. The mercury nitrate is a useful gateway to other mercury salts or to mercury-based compounds. For example, it can be converted into mercury thiocyanate, which is the chemical that's used for the famous Pharaoh serpent demonstration. The mercury thiocyanate is lit on fire, and as it burns, it lets off these weird tentacle things. If any of you are interested in seeing more of this footage, it's from a video I did a year or so ago, and there's a link in the description. I could also add ethanol to the mercury nitrate to make mercury fulminate, which is a primary explosive that was used in bullets and detonators for quite a long time. A long time ago, I did make a video on it, but I took it off because I was afraid of getting a channel strike. It's also possible to isolate the mercury nitrate from the solution, and then to roast it and convert it to mercuric oxide. The mercuric oxide is then converted to mercuric chloride by the addition of hydrochloric acid. As I mentioned earlier, mercuric chloride is a useful catalyst because it easily dissolves into a lot of solvents. This makes it very useful for reduction reactions, like I mentioned earlier in the video. Anyway, I think that's all I have to say about mercury, and I hope I didn't miss anything. Let me know what you guys thought of this video, and also tell me what other elements you would like to see in the series. Keep in mind though that it takes quite a long time to put together videos like these, because I have a lot of footage to collect. A big thanks goes out to all of my supporters on Patreon. Everyone who supports me will see my videos 24 hours before I post it to YouTube, and they can also directly message me. Anyone who supports me with $5 or more will also get their name at the end like you see here.